Afternoon, everyone. Today I'd like to present a topic on sustainable assessment of a data-intensive approach. Um, so till now, you've probably heard a few talk on sustainability assessments, but they are mostly towards the applications of different tools for finding a solution for different type of problems. For this one, we are talking about a tool that is we can apply in different type of problems. So the most of the work I have done for this particular presentations during my PhD and postdoc, and some of the work we are doing right now at IIT Roorkee. Okay, now so what is sustainability assessment? Sustainability assessments has three pillars: economic, environmental, and social. And generally, the economic assessments has not been done through life cycle assessments, but the other two, environmental and social aspects, have been delineated through the life cycle assessments. So before, what's happened maybe 30 years before or so, because the environmental problem is not that prevalent, so people generally look at only designing something, they look at only the economic aspects. But as the environmental degradation is going to happen, we are talking about incorporating environmental aspects too. So that's particular informations you generally try to get from the life cycle assessments or LCA. And after doing the LCA studies, generally people use optimization technique or multi-criteria decision analysis to get into a agglomerated score, so that you can have a better decisions you can get in. Other than that, risk assessments also has been used for some extent to understand the problem related to the particular site, because life cycle assessments also done risk assessment, but they do it for a global scale. So they do not provide the local scale problem that is generally may happens when there is a heavy pollutant load released from a factory or something like that. So from those informations, we probably get a better decisions. So that's what we're talking about today. So the main objective of this particular talk today is that whether LCA is really a good tool for finding the solutions for, or the right informations for environmental and social aspects of our products. So we mostly talking about the environmental aspects. I do not touch the social aspects. So next one, so sustainability assessment as an LCA, it is a comprehensive tool for environmental impact assessments as well as for finding the health impact to the human beings and to understand the resource conservations. The advantage of this particular tools is simulate the supply chain effect. So if you have products, what is the effect from the supply chain you can simulate the life cycle of a product. So suppose a life cycle product means the product has the manufacturing stage, use phase as the disposal phase. You can simulate those kind of problems or those kind of environmental impact through the LCA. And then you also agglomerate those impacts or the pollutants into different impact categories. So you get some extent agglomerated value, but not one single score. The disadvantage of this particular issue, this tool is it is very data intensive. Data quality certainly be an issue. We're talking about those things later. And then the other issues are other unforeseen issues. Suppose if you're doing studying a particular product, you find some of the problem that is probably not there in literature. So how do you handle those kind of things? So we're talking about few of those things and see how the variability actually occurred in life cycle analysis because of those reasons. Now this is basically a framework for life cycle assessments, and it is not like a mathematical tool or anything like that. It is very much a set of regulations and recommendations that is given by either ISO, that is International Standard Organizations, or CTAC, the Society of Environmental Toxicology and Chemistry. They are the two governing bodies. They basically formulate the goals, the regulations or the recommendations for life cycle assessments. Now, in general, the life cycle assessment has 4 steps. Sorry. The 4 step: goal and scope definitions, inventory analysis, interpretations, impact assessment, and interpretations. And this particular tool has been used for different aspects. For example, they used for product development and improvement. So if you make the thing that they have the product is low impact products, you can use the LCA. You can use for strategic planning. It is used for public policy making some extent, and you've probably heard about different like carbon footprint analysis, carbon footprint of a products. You probably heard about the eco labels. Those are all actually the done through the LCA. Okay, so LCA has a numbers of applications. Now the question is whether the LCA is capable to carry out those above applications effectively. So we talk about few of those things later in these slides also. Okay, so now what is in LCA? We have 3 phases I told you. That is the production phase, use phase, and disposal phase. And what we do basically in each phase, we try to find it out the raw material use, energy use, water use, whatever the materials you are using to produce that product or to make or during the use phase, and then agglomerate them to different impact categories. So these are some of the impact categories, but not the exhaustive list of the impact categories. Now next slide shows some extent the how you done that thing. You have an input of those data, and then you agglomerate them through characterization factor. That is the impact factors basically. Those characterization factors are the impact factors, and then you come into different impact categories depending upon which impact factors you are using. There are several impact factors or impact methods are available. So we are talking about mostly here is the CMLCA. It is a chain management LCA. So that is probably we are talking about most over here, and these are the time frame. So they are basically done in 3 time frame: 20 years, 100 years, and 500 years. And why it is so, I talk about those things also in later. Now this diagram shows the indicator or impact categories, but I am just trying to tell you that there are 2 types of impact categories available. One is midpoint categories. So one is midpoint categories, these are midpoint categories, and other one is the endpoint categories. Midpoint categories means you look at the impact of those particular pollutants into a different sphere. Sphere means it is in the air, in water, or in the biosphere. And in the endpoint means you are looking at the impact to the human health and the economy. So ultimately you use those data to translate to the human health, that how much mortality is going to happen to the risk assessment approach, and you find those endpoint indicators. But generally people use midpoint indicators because it's better, it has a better data quality and uncertainty as compared to this data. The next one is basically we are talking about the inventory analysis, how inventory analysis has been done. So it is this particular diagram shows basically a very much a random one to produce biodiesel, and for making biodiesel you have a number of processes going on, and this process is not also exhausted. So depending upon, so for example, you have to produce biomass, you have a nitrogen fertilizer productions, and for that you need energy and other raw materials. And then after finding all those input and output from each of the processes, you develop the inventory and then agglomerate them to a different impact categories. Now this particular box shows the system boundary. It is basically in the LCA literature it is tailed as depicted as system boundary. System boundary can be different for a same products, and it is basically very much dependent on the users as well as the time requirement as well as the data availability, we basically make the system boundary. So, depending upon the system boundary, the output may be different. Now, when for the impact assessments, that is the calculation factors you are using is basically derived by some other researcher. We do not derive, basically as LCA practitioner, I do not derive those impact or the calculation factors. But we sometimes derive, if it is not available, some of the cases we derive the calculation factor, but most of the cases is derived by the other researchers. And what they do, they use a freight transport model that is a global in nature. So, suppose something going on in Kharagpur. So, when something emissions going to happen, it is basically distributed globally. So, then they use a partition model or multimedia model to partitions those pollutants into different sphere, like in soil, water, air, and from there on they find it out what the concentration of those products, those pollutants, and from there on they find the midpoint impacts. And after midpoint impact, if you have a toxicity data for those pollutants and you do risk assessments, you find it out the endpoint indicators. But the impact categories that is derived by midpoint as well as endpoint categories, they are highly variable with respect to time and geography, because these models has probably millions of parameters, and these parameters are different for different continent or different climate conditions as well as soil conditions. So, depending upon those variability, your input, your output may be different depending upon the geographic locations and the time. Now, this particular diagram shows how variable are those numbers. So, here we try to develop the impact, and these are basically human toxicity and those are the terrestrial toxicity, and we do it for different material that is used in road constructions. And if you see the variability, it is variable, variability is around, the variable is around 40 order magnitude. So, 40 to 50 order magnitude they varied, and that is because of the variability in the impact categories or impact calculation factors. Next variability can be happens or introduced in the LCA, because I told you before that is because of the system boundary, and this variability to some extent you can gauge, because nowadays what's happened, the new regulations or new recommendation come in, they are talking about the tier approach. So, tier approach means the tier 1, tier 2, tier 3, and they already give that what processes you should include in tier 1, which processes you to take into tier 2 and which processes you take into tier 3. So, if you do those way, and then the comparisons of the numbers will be more easier, but if you look at literature, very few people actually follow these guidelines. So, it is very difficult to compare the result even from the same products. The second problem, second type of input, second type of LCA that is used is called input output LCA, because in process based LCA what happens, you basically develop or integrate different processes to make products. So, for a particular product, for example, I am using this microphone or I am wearing these shirts. So, these shirts probably need some kind of service industry too. For example, they need some administrative people to do the things that is supporting the shirt manufacturing and transport, all those stuffs. This is very difficult to gauge by process LCA, forget about other processes and all those stuffs. So, in those type of problems, if you use the input output model, that give you a better number, but they have other problems. So, and if you use two different, one is process based versus input output LCA, your number also be different. Now, if I look at a number in a LCA result from a particular products, if it is a, it says x kg of GHG emissions going to happen, GHG means greenhouse gas emissions, or that particular products basically consume y kg of water used per unit of that particular products is produced. For me, it does not mean that this particular number is very much accurate. They can vary from a number of by a magnitude or maybe a factors. So depending upon products, depending upon your experience, you get gauge that how those whether those numbers are outlier or it is basically within the range for other if you study the other LCA. So it is very much experience oriented. Now, for example, these LCA is used, or policy making agency saying that, okay, I have to reduce the greenhouse gas emissions for a particular product by so and so %. So 5 minutes. So is it mean anything to me? It is certainly very vague to say that percentage of reduction of GHG emissions, how you can reduce, because your numbers is so much variable. So they need to have a better descriptions that how you can improve or how you can reduce the GHG emission. It is using the tier 1 approach or tier 2 processes. So that should be given, but most of the times those things are not given. So it is very much become vague to understand what they mean by that. Now the LCA, in the new type of LCA that is now developed, it is basically now we are talking about the variability with respect to the process. Now the LCA can be dynamic. That means with time the result from LCA output can be variable. Okay, and before most of the studies has been done in steady state, but nowadays we are talking about dynamic LCA. So in dynamic LCA can be produced because of the using a dynamic model before in LCA models, or you are using a factor. These have to be factors that are temporal functions. So if you use those kind of informations in your calculations, then your LCA is dynamic. For our case, what we found that if I use nutrient recycling, that is generally happens in waste-based biorefinery, the systems also be some extent dynamic, but this dynamism is some extent similar to the whatever these guys Ming Zhu from University of Michigan are developed. So it is not essentially some extent is similar. So other than that, so how those numbers are changing because of these dynamisms. For example, in our study we found that the energy productions is increased by 600% because of the nutrient recycling from the original values. But if I look at the GHG emissions and energy demand with respect to the product produced, they are insignificant. That means the dynamism does not affect much these two impact categories. Now similarly, if you do different scenario analysis, because suppose for example you can produce a product by different processes. So depending upon different processes, your number may be different. Other approach, other one, the changes coming that is recently published. Suppose for power plants has a base load as well as a peak load, and it was found that in base load conditions the power plant works hours. Now if you incorporate those data in your products development, depending upon the energy intensity of those products, these numbers, the energy demand of a particular products may be what is called may be significant, may not be significant, depending upon the energy that particular products is using. Now next one is the end of use of biomass. That is basically generally happens in biomass based biofuel production. So we produce a residual biomass that is basically applied on the land as a soil amendment. That is also happens for wastewater sludge too. And according to the IPCC guideline, it says that 10% of the carbon that is present in the biomass is sequestered. But these numbers can also be challenged, whether it is 10% really a 10%, but because I do not go into the details of those, how they get into those numbers because of the time limitations. But I am saying that when I am using those, their model called DNDC model is a model, biogeochemical model that's basically simulate the GHG emissions for biomass productions. And it is very much established models. And if I use this model to find the GHG, the carbon sequestration in 5 different states of the US, we find different number, but it is still okay, it is not that much different. But if you think about the Indian conditions, if I do the change the clay content to 40%, the carbon sequestration is increased to 43% as compared to 10%. So it is some extent 4 times increase. So these are some of the variability that is you found depending upon your products and type of LCA that is you are using. The next one is, so we have find very much different data from the DNDC. We develop our own model and we found that depending upon the parameter you are using, the around 5 to 16% of the, sorry, in this case where I am actually applying, I do not go to this one. So when I am applying on the land, the biomass, nearly 5 to 16% carbon is sequestered. So that is close to the IPCC guideline, but our model is more I can say very simple model. So now the question is which model I should rely on. Okay, so these are the some of the problems you have depend, and it is maybe different for another products. And so what I found that's okay, there are so many variabilities there for life cycle assessments results. So whether I able to use this result for decision making? Yeah, for me it is. For output of the LCA model are highly variable, but if you have some kind of gauge that what is the range they can come, you can able to use those things for the decision analysis. So that is depends on the interpretations, depends on the decision makers at least and their experience. LCA can be implemented for policy implementations, but it also depends upon that whether policy has given enough guideline to do that. But it is difficult to use for trading. So suppose for example carbon trading is basically a very much common thing nowadays, but they are basically done through voluntary declarement. It is not done by legal issues. So if it is a legal issues there it is basically very difficult to do because there is a lot of variability in there. Anybody can questions your numbers. Okay, thank you very much. So that is all about my presentation today, and these are some of my the funding agency and some of my supervisor who actually help us to do this work. And if you have any questions, please feel free to ask me.